So hello and welcome to Online Study for You, a complete placement solution. So friends, in this video, I am going to discuss with you some coding question and pseudocode that were asked in recent examination of that October month. Okay, so let's first start with the pseudocode problem. Then we will move to the coding problem. Okay, so the first problem that we are going to discuss today is this one. I hope this is visible to you. Now, this is a pseudocode problem, and here some statement is been written. So let's try to solve it. Okay. Now, so what is the first statement that is being written here? You can see we have been given three integer named as pp, qq, and rr. So first we have to write that we have given three integer pp, qq. Okay. Please tell me if this color is okay now. pp. Let me small it down something. PP, QQ, and RR. Okay, these three integer has been given to us. Now, in the next line, what is given? You can see the value is being assigned to all the three integers. That is PP value is 2, QQ value is 4, and RR value is 5. Now, what has been written here? You can see if RR plus QQ plus PP is less than QQ plus PP plus RR. So we have to check RR plus PQQ plus PP, what it would be. So 2 plus 4 plus 5 would eventually get us 11. Okay. And QQ plus PP plus RR will also get you 11 because you can see there is some trick is written here. Let me zoom it. Okay. Here both the number are written to be same. The three variable are to be added, but the order of adding is different. But in addition, the order doesn't depend. Okay. So how the three value which are to be added together would have get the less output than other. So this condition is false, and you can also check it by simply putting that value over every variable and then check that. Okay, so this value will become 11, and when you add all the three, this is also get you 11. So 11 can't be less than 11 because these two are equal value. That means that this statement is false. So we don't have to execute the condition or statement written inside the if condition. Okay, so now, so where we will move to the else part. Okay, so now inside the else part there is some instruction is been written. So here instruction is that we have to change pp equal to 10 plus 6 plus qq. So 10 plus 6 will eventually will be 16, and qq will be, what is our current value of qq? That is 4. You can see from here. So qq will be 4. So 16 plus 4 will eventually equal to 20. So now our new value of p is 20. I hope you understand this. Now, so now this if condition is being over. Now we will move to the next line. That is this. Here again, one if condition is being written. So what actually this statement wants to tell us? That if our QQ plus RR, QQ plus RR will be now, our value of QQ is 4 and our value of RR is 5. And when we add them both will become 9. If 9 is greater than RR, what is the value of RR? 5 minus QQ. QQ value is 4. So that will eventually will become equal to 1. Is 9 is greater than 1? Yes, it is true. That means that this condition will return me true. So I have to execute the instruction written inside the if condition, and the instruction is, as you see here, pp equal to pp plus 3 plus qq. So I have to execute that. So now value of pp is currently 20. So 20 plus 3 will eventually become 23, plus the value of qq currently is 4. So 23 plus 4 will eventually become 27. So now new value of pp is 27. So let me change pp to 27. Now this end if, that means that our if condition is now ended. Okay, now we will move to the next statement, that is print pp plus qq plus rr. Print means we have to something output. Okay, give output. We have to print And what we have to print? PP plus QQ plus RR. So PP is 27, QQ is 4, and RR is 5. And when we add them both, 4 plus 9 will, 5 plus 4 will eventually become 9, and plus 37 will eventually give you the output as 36. So my correct output is 36. I hope you understand this problem, how actually I got that answer. So correct answer is actually option D. So now let's move to the next problem. So next problem is given here. Okay, it is a very important problem, friends. Please understand this carefully. Okay. Now, here I have been given a function. Okay. And inside the function, the two argument is given, integer a and integer b. So a and b are the two argument, and value assigned to a is currently 2 and b is 4. So currently value assigned to a is 2 and b is 4. Now, what we have to do? We have to move to the next line. Okay. And inside this function, the first line is a conditional statement if. And inside the if, there are some instructions being written. Now, the first instruction is a is less than b. So our a currently value of a is 2 and our b is 4. So is 2 is greater than 4? Yes. So it is a true. Okay. So it is a true case. Now, this is a logical AND operator, friends. Okay. So you have to understand this very carefully. What is a logical AND operator? So let me first write it. What is a logical AND? So, okay. Logical and or this will be represented as like this. So what actually logical AND will give you? So logical AND will tell whenever we are comparing two value by logical AND, then this table will be followed. The table is, if let's say this value will be A and B and we are taking logical AND of them. If both of them are true, if both of them are true, then overall logical AND will return me true. Okay. If true and true will return me true. If any of them are false, then it eventually return me false. So if first is false, the second one is true, then also it will return me false. If the first one is true and second one is false, then also it return me false. And if both of them are false, then it has to return me a false. I hope you understand what actually logical AND is. So logical AND will return me true in only this case, okay? When both of them are true. Okay, now come here. So now what actually happening here? Let's see. So now this will be true and logical AND. Okay, now for this if condition to return true, both of them should return true. Then only the logical AND will eventually return you true. So this is true. Now check for this condition. It is written here a minus 2. Let me erase it here. A minus 2 will eventually, a value is initially 2, you can see from here, and 2 minus 2 will eventually get you 0. If 0 is less than b and 7. Now, what actually this AND is? This AND is a logical AND, I have told you. But you can see here only single AND is being written. So what is it? It is same as this? No. The single AND is actually a bitwise AND operator. You can see also the instruction is been written to you. Here you can see the bitwise and logical AND definition is being written. But don't worry, I will be explaining you in detail, okay? So what is actually bitwise AND? Try to understand from here. Okay, well, let me take the phrase. Okay, now, so bitwise. So it is actually a bitwise operator, okay? So bitwise AND. Now, bitwise AND operator will actually work on whom? Actually on the bit value, okay? What is a bit value? Okay, I have already made a video on bit manipulation, okay? Now, but let me explain it to you here. So actually, you can see what value of B currently? Value of B is currently 4. So actually, the problem here written as 4 and 7, okay? Because B in 7 is being provided there. So this 4 or this 7 is actually called as a decimal values, okay? This is called as a decimal values. But when we are applying bitwise and then this decimal value should be converted into a bitwise value. And what is a bitwise value? Bitwise value is only in the form of 0 and 1. Okay. Now, how you will convert any decimal value to a bitwise value? Okay, so there is a formula. You should have to divide that decimal value by 2. Okay, let's say that you see here, I have to divide 4 by 2. Now, this will get me eventually 2, and the remainder I'm writing a remainder here. So when I divide 4 by 2, then eventually the remainder will only be 0. Understood? Now again I divide 2. Again the remainder, this will get me value here 1, and the remainder again will be 0. Okay. Now when this will become 1, okay, when this will become 1, then I stop dividing, and what I will do, I will write from this side to this side. So starting right from 1, 0, 0. Okay, you can say start from bottom, go up. From the bottom, we have to go up. Now, what is actually this 100? It is a binary representation of 4. Okay, because 4 is a decimal value, and when we change it to bitwise value or binary value, sorry, so it will actually become 100. Okay, I hope you understand this. Now I have to convert 7 also. Okay, so same thing is happening for 7. 7 is being divided from 2. Here I am writing the remainder. Okay, when I divide 7 by 2, then the actually the quotient will become what? 3. 3 to the 6, and remainder will become 1. Okay. Now again I divide 2. Now again the remainder will become 1, and this will become 1. 1 to the 1 plus 1 will eventually get to 3. Now when this will 1, I will have to stop and I print from bottom to up. So the 7 bitwise representation is 1, 1, and 1. Understood? The bitwise representation of 4 is being also I get, and bitwise representation of 7 also I got. Okay. There is one more trick to find bitwise operator, but I will be telling you this in later part of this video when we are dealing with some large decimal value. Okay. Now let's understand this topic till here and try to find the bitwise AND of both. Okay. Now, I hope you get that how actually I convert binary decimal to binary. Now, what I have to do? I have to do 4 and 7. So first I have to convert this to their decimal representation. The 4 decimal representation will be 100, and 7 decimal representation will be 111. And I do AND of both. Okay. Now, what is the rule of bitwise AND operator? What is the rule of bitwise AND? So it is telling us, let's say if I taking bitwise AND of two values, okay. Now, so if both of them are 1, then only the value will return me 1. And if any of them are return me 0, let's say if this one is the second one is 0, then also it will get me 0. If first one is 0, then also it will get me 0. And if both of them are 0, then also it will get me 0. Sorry, I have misspelled it here. It will get me 0. So there is only one case where bitwise AND will get me 1. And in all the other case, it will get me 0. Understood this? Now, so I have to take the same value here. So 0 and 1 and 0 will get me eventually 0. Okay. 1 and 0 will get me 0. And here you can see both of them are 1. So it will get me eventually 1. And now you can see what value I have get 100. So it is actually a binary representation. Now I have to change it to decimal. So I told you how to change from binary to decimal. Now I'm telling you how you can change a binary value to decimal value. Okay. So it will be nothing serious. Just you have to consider the place value. Okay. There is one rule. Okay. You have to understand this, that this is zeroth index. This is okay. 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 Let me change the color. Try to understand this very carefully, because this question on bit is very much asked to you in Accenture examination. That's why I am discussing with you it in so much detail. Okay. Now this is zeroth position, this is first position, and this is second position. Understood this? Now, this is called as the position. So what is the value? Okay. How you can find? There is a formula. That formula is the value here. Okay. This is called the value of this place. Okay. So value to the power. Okay. So value into 2 to the power the position. Understood this? Value into 2 to the power the position. So this is the formula. Okay. So initially you can see the value is 0. So 0 into 2 to the power the position is 0. So if anything is multiplied by 0, so it will eventually get you 0. So don't have to do anything. So it is 0. Now the value of next position is again 0 into 2 to the power 1 because the position of that is 1. Again, this is again 0. So don't have to do anything. Now the second position value is 1. So 1 into 2 to the power 2. Okay. Because the position of that value is 2. Okay. So 2 to the power 2. Now what I have to do? I have to add all of them. Okay. So it will get me 0. It will again get me 0. And it will get me what? 2 to the power 2 will get me 4. So it will get me 4. So 0 plus 4 will eventually get me 4. So that means the I converted this binary to decimal. So the value I got as 4. And you can also see that when I change 4 to 0, 4 to binary representation, then that value I got the same value, that is 100. So I hope you understand that how to convert any number from decimal to binary and then reconvert it from binary to decimal. Okay, there is this formula you just have to follow. And there is some more trick also that we are going to tell you in the upcoming part of this video. Okay, but now just try to convince that. Okay, so now what actually this will get me? This b and 7 will eventually return me 4. So now you can see 0 is less than 4. It is true. So this condition is also true. Now both of them are true. So according to the logical AND operator, if both of them are true, then we get the true. So that means that eventually this if condition will return me true. And whenever the if condition will return inside the if condition, the statement will return me true, then I have to execute the statement written inside the if. So this is the statement written inside this if. So now statement is b equal to b plus 2. Okay, let me erase this all. Don't need it now. Okay. So b equal to b plus 2. So b equal to currently initially the value of b is 4. So b equal to b plus 2 will get me 4 plus 2, that will equal to 6. So now the new value of b is 6. Let me update it here. Now again b equal to 2 plus 3 plus a. So 2 plus 3 plus a value is 2. So that will eventually will be equal to 2 plus 3 will be equal to 5. And now plus 2 will equal to 7. So new value of b is now 7. Now again, the next line will be a equal to a plus 2. So initial value of a is 2. When I get a equal to a plus 2, that means 2 plus 2. So new value of a will become 4. Now you can see it carefully. What actually written here? It is written that return b minus, again the same function is being called because this funn is the same function that we are currently working in. So what actually is this? When a function called itself, then it is basically a recursion. So it is a recursion kind of problem that are to be asked to you in pseudocode. Okay, so try to understand this in very detail. So now, when we go to the next line, so this line will get me return b minus, so currently value of b is 7. 7 minus the same, let me erase it. 7 minus the same function is being called. The same function is being called again. So now the same function is being called, but the value inside it will be passed as b and b. And current value of b and b are 7. So 7 and 7 is being passed. This is the recursion. So this the function already that we are in called itself, that you solve again yourself for some other values that is 7 and 7 and return me the answer. Okay. So first we have to solve now this function to get back to him that, oh, what the value I got from him. Okay. Now, so this function 7 and 7, let's try to execute it again. Now the same function, let me erase this from here. Same function is being called. Now The value of A and B are now, let me write it here. A and B are now 7 and 7 for this function I am calling. Okay. Now the new value of A is 7 and B is 7. Okay. Currently working on this function. Now I have to check if 7 is less than 7. If 7 is less than 7, no, because currently value of A and value of B are both are equal, and I am writing checking the first statement inside the if condition that A is less than B, and value of A is also 7 and B is also 7. So if it is possible that two values that have same values are lesser than one another, no. So this will return me eventually false. Okay, let me change the color. So okay, just once wait. So this will eventually return me false. Understood this? Now this is logical and according to logical AND operator, the logical AND, let me write it, will only get me true when both of them are true. If both of them are true, then it will get me true. And if any one of them are false, then it will return me false. Okay, false or false. So now, if first statement is already become false, do I have to check for another statement in logical AND? No, because I simply say that if any one of them are false, then eventually the total function will return me false. So now this is false. So this whole will become return me false. And when the if condition will return me false, then I don't have to execute the instruction written inside the if condition. And these all are the instruction written inside the if condition because this if condition is being ended here. Okay. So I don't have to execute all of this condition this time. So I simply move to here and here end if is written. So I don't have to do anything, just move forward. Now the next instruction is written me return b plus 1. Okay. Just remember we are working on this function. Okay. So now this function will got return b plus 1 and the value of b is 7. So return 7 plus 1. 7 plus 1 will be 8. So 8 will be returned, but where it will be returned? It will be returned from where it will be called. So it will be called from here. So that's why it will be returned to here as well. So this will return the value what? 8. 8 will be returned to here. So now this function will be returned as 8. It will be returned at S, and now the currently this B for that original function, that is this one, is 7. Okay. So 7 minus 1 is 7 minus 8 will actually equal to minus 1. And this will also be returned. And where it will be returned? It will be returned to my output because this is the original function that is being called to us. Okay. So minus 1 is being returned where? To the output. So here you can see the minus 1. This option will be my correct answer. So C will be my correct answer for this problem. So it is a very important problem. So you have to understand this in very much detail. Okay. Now just move forward to the next problem. Now the next problem is here. Okay. And here we are going to discuss about the trick of the bitwise operator. Don't worry. Okay. So now first what the instruction is given, the integer pp, qq and rr is been given. So I have just three variable pp, qq and rr. The initialization of pp, qq and rr is given in the next line, that is pp is 9, qq is 6 and rr is 4. Now the pp equal to 12. What is this? This is you can see it is written at exclusive OR. This is a bitwise exclusive or we can say it as XOR. Okay, it is also called as a XOR. Okay, so here written as 12 XOR RR because XOR is being represented by this 12 XOR RR and the value of RR is currently 4. So 12 XOR 4 is been actually written here. Understood this? Now this is actually a bitwise XOR. And when I write bitwise, that means that we have to change first the decimal values, that is 12 and 4 to first the bit value. Now, I already told you how to change any decimal value to bit value. Simply start dividing it by 2 and stop when the value will become eventually 1, and then start printing from bottom to top. That is the way. But here I am going to tell you a trick. Okay. Now the trick part tells you this, that the you have to just write the power of 2 from 0 till how many values you want. Okay. So what I want to tell you, so 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. From right to left, you just have to write. Okay. And till how much you write? You just want to write till this value do not exceeded the value that you want to get. Okay. So here I want to convert the 12 into binary. So I first write 2 to the power 0 will eventually 1. 2 to the power 1 will eventually get me what? 2. 2 to the power 2 will eventually get me 4. 2 to the power 3 will eventually get me 8. 2 to the power 4 will eventually get me 16. Now you can see I got the value which is greater than 12. So I simply stop it here. Now, what I have to do, listen carefully here. I want to convert 12 into binary number. Okay. So, I mark the value inside. This is the value. Okay. I marked 1 in, below that value which I want to take to make the total value possible as 12. So, you can see how actually I make 12. I simply add 8 and 4 and it will get me 12. Understood? So I have to take 8 and 4 from this table. So whichever value I want to take, I simply mark it as 1. Here 1, 8 and 4 is marked as 1 and rest of all of them are marked as 0. I mark, listen carefully. I mark that value which I want to take from from whose combination I want to get that value. So here, if I want to get a 12, so I mark whom? I mark 8 and I mark 4. Okay, just once. So I mark 8 and I mark 4, and then rest of them I mark as 0. So now, if you simply observe, what is this actually? The right size 0, we can this the value in the right most. If it is coming as 0, then you can simply ignore it. Okay. So simply we can start taking from the first one. Okay. So this is 1, 1, 0, 0. Now what is this? This is simply a bitwise conversion or binary number conversion of this number. So you can see simply using this trick, we can get this value in seconds. Okay, so this will eventually help you to save your time. You can find this change this decimal number 12 into binary simply by using that dividing technique. There is no harm in that. But in that technique, you will eventually losing some time, which you can save if you know this trick. Okay. So this is a very important trick that you should know while solving the pseudocode in any examination. Okay. Because time is the key. So now, again, if I again have to follow same trick for 4. So for 4, also I write to first from the left I write the table to the right. So initially the first number is 1, which is 2 to the power 0. Then 2 to the power 1 will eventually get me 2. 2 to the power 2 will eventually get me 4. And I got the value 4. Okay. Now don't have to do, because from till where I want to write my table, till I not get the value of larger than the value which is I am trying to find. So I trying to find 4 and I got the value 4. So I simply stop it here. Okay. But if you want to write the next number as well, it will be 8, because 2 to the power 3 will become 8, then 16, then 32, then 64, then it eventually goes from increasing in 2 to the power. Okay. Now I want to get 4. How actually I get 4? I simply see this table and I simply have to take 4 from it. Okay. To get my value as 4. So I simply mark this as 1 and rest of all of them as 0. So now if I can simply view it here, so my conversion of 4 to decimal 4 from to binary is eventually 100, because I can ignore this. So 1, 0 and 0. You can see this, and so these are the simply the binary decimal to binary conversion of any number. You can follow this trick and simply in seconds you can get your values. Now I hope you understand this. Now let me discuss it. What is actually a bitwise XOR operator? Okay. Okay. Let me do. So bitwise XOR, it is a table. Bitwise XOR, if the two value that you are comparing, if both of them are different, if both are different, then you get 1, and both are same, then you get 0. What it means, let's say if you are comparing two value, and if both of them are 1 or both of them are 0, okay, then you simply get 0 because both of them are same. But if one of them are 0 and other one of, sorry, one of them are 1 and other one is 0, or first one is 0 and second one is 1, that means that both the value that you are taking XOR with is different, then you simply get 1. Understood this? I hope you understand. Now let's move to the next function. Okay, so now if I want to take the XOR of these two, so let me write it. So 12 will be written as 1100. Now this 100 will start from where? This will start from this. So this will come here. So this 0 will come here, this 0 will come here, and this one will come here. And if nothing is here, you can consider 0. Okay, if nothing is here, you can consider simply as 0. Now if I take XOR of them, okay. So here you can say both value are same. So bitwise XOR is eventually 0. Both of them are same, so it is 0. Both of them are same, it is 0. Now both of them are different, so it is 1. So this is simply a bitwise XOR of these two binary number. Now what I have to do, I have to convert it to my, again to uh, what, again to the decimal number. Now here you also have to know the trick. So the trick is simply nothing but the simple trick is there, that again you have to write the same, that is it, this place is 2 to the power what, 2 to the power 0, so it is actually 1, this is 2 to the power 1 is eventually 2, this is 2 to the power 2 which is eventually 4, it is 2 to the power 3 which is eventually 8, again 2 to the power 4 will eventually 16, in the same way 32, you can go further, but I just have to stop the value till it is here. Now what I have to do, I have to simply take the value which is 1. So you can see the value 1 is only the value 8. So I can only take the value 8 because none of them other one as marked as 1. So I can simply take 8 here, and I take 8 and I return. So 8 is the value that I got by taking XOR of 2. So 12 XOR 4 will eventually get me 8. I hope you understand. Okay. So now this 12 XOR 8 will return me 8. Okay. So 12 XOR 4 will eventually get me 8. So now, so this PP will now become 8. Understood. I'm taking, I know you thought that, oh, this is taking so much time. It is not taking so much time if you practice it well. I'm just explaining you everything in detail. So that's why this video will be coming, looks like a lengthy video. But if you know all the trick that I have told you, if you will practice it well, then I'm sure that you will able to solve this problem in just a minute, okay? Or even less than that. Now, this 12 XOR 4 will eventually get you 8. Now you have to do the next function, that is RR and QQ. Sorry, RR will equal to 2 and QQ. Now this AND is actually bitwise AND. Okay. If so, let me. Okay, no, this not will erase it. So let me come here. Okay, let me erase because this is being done. So now the next function is actually again the XOR operation. That is the XOR operation is RR is equal to 2 and QQ, and QQ value is currently what is 6. Okay, so because this, so QQ, let me, okay, 99 is again changed to 8, and now QQ value is 6. So 2 and 6 is being written, and bitwise and I have told you what is it is. If both of them are 1, then it will return me 1, and in all other cases it will return me 0. I have written, where I have written, okay, here I have written bitwise and that if both of them are 1, then return me 1, and in all the other cases it will return me 0. So now come here. Okay. So now what I have to do, I have to convert 2 to first binary representation. So 2 will simply convert it. You can write 1, 2, 4, 8. Now this is 2 will only this, okay? This will mark as 1 because this only will be needed and rest all of them are 0. So binary representation of 2 if I write is only 1 and 0. Now if I have to take the binary representation of 6, again let me write the same 1, 2, 4, 8. I will stop it here. Now for getting me 6, what I have to do? I simply have to add 4 plus 2 because 4 plus 2 will eventually get me 6. So what I have to do? I have to mark 4 as 1 and 2 as 1 because 4 plus 2 will get me 0. So I have to take these two part. So which part I have to take to get that value? I simply mark them as 1. Rest of all of them are 0. So binary representation of 6 are 1, 1 and 0. Now what I have to do? I have to take AND of both of them. Okay. So let me take AND of both. So 2 and 6 will get me 1, 0 and 1. Sorry, let me 1, 1 and 0. Now nothing is there, so I will take 0. Now I take AND of both of them. So 0, 0 will get me 0. Now here you can see both of them are 1. So this will get me actually 1. Now this is 0 and this is 1. And if any of them are 0, then it will get me 0 in the case of bitwise AND. And now this is the value that I get. Now I have to convert it into decimal. So how actually I convert? Let me write the value. So this place value is 1, this place value is 2, this place value is 4. Okay, now you can see only this is 1. So I can take only this value. So the value I will have to return is only 2. So now 2 will be returned. Okay, so this will eventually return me the value as 2. Okay, let me erase all of them. So this will actually return me 2. Okay, so now the RR value will now become 2. So 2 will be assigned to RR. Now again the AND operation is being done. So here the multiple bitwise AND is been given. Okay, so PP is equal to RR and QQ. I hope you understand. PP equal to RR and QQ. So okay, where I have to edit the space is being ended. Okay, PP equal to RR and QQ. So PP equal to RR and QQ. So the value of RR is currently 2 and value of QQ is currently what 6. Okay. So simply I have to write 2 and 6. So now I am doing all the thing fastly. Okay, because I thought I have understand you. So value of 2 is eventually I making it here 1, 0 and the 6 is eventually 1, 0, 0. And the same I have to take. So 2 and 6 I have already taken. So the value will be returned as 2. Okay, so I don't have to do the same thing again and again. Okay, so it is the same thing. So now 2 and 6 will eventually return me 2 and it will be stored where? It will be stored again. Okay, change the color. So it will be stored in PP because if I zoom it, so it will be stored in the PP. So 2 will be stored here. So now my PP will now become 2. Hope you understand. Now again, QQ. Again, the next operation is this will be also done. Now QQ is PP XOR QQ, PP XOR QQ plus RR. Okay, now come here. So PP XOR QQ and plus RR. I hope this is the same function. PP plus QQ XOR RR. And the value of PP is 2, QQ is 6, and RR is 2. So PP plus or QQ plus RR. So PP is 2, QQ is 6, and RR is 2. So first I have to do this, then I will add them with 2. So now 2 is or 6. So the bitwise value of 2 is 1, 0, and 6 is 1, 1, 0. Now if I take 1, 0 and 1, 1, 0, let me take it 0 and take the XOR operation of them. Now, what is your? If both of them are same, then it will return me eventually. Okay, where I have written? Here. If both of them are same, then return me 0 and different, return me 1. You can see both of them are same, so it will return me 0. Both of them are same, return me 0. And here you can see both of them are different, so it will return me eventually 1. I hope you understand. Now I have to convert it into the decimal as well. Okay, so this place value is 1, this is 2, and this is 4. And you can see only this value is 1, so I have to consider only 4. So I will return 4 from here. Okay. So 4 is being returned and the whole value of this will become 4. And now 2 will be added to it of this RR. Okay. And the whole value will become 6. Understood this? Now, so this will get me eventually 6. So 6 will be stored here. QQ will become 6. So it is actually a 6 already. Okay. So don't have to change it. Now, what I have to do? Now I have to print. That means get the output. So PP plus QQ plus RR. So PP is currently 2, QQ is 6, and RR is 2. So it will eventually get me 10. So it will get you 10. So this is a very important question, friends. You can see I have taken so much time to explain you in detail because I don't want to instruct you in that problem. And if this kind of problem is been asked to you in exam, then you simply use this technique that I have told you, that how actually you convert the decimal to binary and binary to decimal. And you should also know the rules, that what is the rule of logical and bitwise or bitwise sort. You actually have to know, and this is also written in the note also. So you simply write the note. If you forgot the note, the truth table, that this table is actually called as the truth table that I have written it here. It will actually also will be provided to you there. So you have to know how to convert decimal to binary and binary to decimal to perform your bitwise operation there. Okay. Now, this is the third question. Now, let's discuss about this last question. Then we will directly move to the coding part. Okay. Now, what actually, let me erase it here first. What this question is, okay. So here also the three integer is given P, Q, and this is being given there. Now, value is being assigned to P, Q, and R also. Okay, so P value assigned is 5, Q assigned as 6, and R assigned as 6 also. Now, Q equal to 6 plus 1 plus Q. 6 plus 1 will be 7 plus Q. And Q is, value of Q is 6. Okay. So now 7 plus 6 will eventually will become 13, and it will be assigned to Q itself. Okay. So Q will become 13. Now you can see, so this step has been done. Now I have to move to the next step, that is if condition. So inside the if condition, there is written this function and this function. Okay. So you can see this is a simply a XOR. This is simply a here something trick also given in that problem, but I will be explaining you it later. First, let me find it by simple method. Okay. So the method is written as if this function, what the function is written, R XOR Q is less than P. So I have to first find the R XOR Q. Okay, what is bitwise XOR? I have already explained you. The value of R is 6 and XOR Q is 13. First, what I have to do, I have to convert it into the binary. So 6 binary, I have already concluded that 110. But the value of 13, for that, I have to draw the table again. That is 1, 2, 4, 8, 16. Now I will stop. Now for 13, how actually I got 13? You can see from this 8 plus 4 plus 1. It will eventually get me 13. 8 plus 4 will be 12 plus 1 will be 13. So what I have to whom I mark? To 8, to 4 and 1. So I will mark 8, 4 and 1, and rest of them are marked as 0. So the bitwise binary conversion of 13 will be 1101. Understood this? Now I have to take the XOR of them. So XOR will be 1101 and 110, and nothing is here, so I will simply write 0 here. XOR has been taken. So here you can see both of them are different, so one will be taken here. Now here also both of them are different, so one will be getting. Both of them are same, so 0 simply will be getting here. And here you can see both of them are different, so again one will be getting here. Now, so now again I have to convert this to the decimal. So it will be 1, this place value is 2, this place value is 4, this place value is 8. Now you can see this value is 1, this value is 1, and this value is 1. So I have to take all of them. So 8 plus 2 plus 1. So 8 plus 2 plus 1 will eventually equal to 11. So the value which will be returned from this will be 11. So this is 11, and it is if 11 is less than what is P? P is 5. Is 11 is less than 5? No. That means that the statement that is given here is a false statement. So this is a false because 11 is not less than 5. Now, what actually this? What actually this? So you have to know it. This is actually a logical OR. I've already explained you the logical and in previous question. It is a logical OR operator. And what actually logical OR will tell you? Logical OR will tell you if any one of them are true, then you should return true. The logical AND will tell you that if both of them are true, then only you return true. But logical OR will tell you if any one of them are true, then you will return true. That means that if I take A and B, sorry, A or B, okay, it will eventually get me if this is for true and this also is true, then it will return me true only because both of them are true. If first one is true and second one is false, then also it will return me true. If first one is false, second one is true, then also it will return me false. But if both of them are false, then it will return me false. So it will return me false in only one case, that if both of them are false, then you should return false. And if any one of them are false, true, or both of them are true, then you should return me true. So now this will return me false, but since it is a logical OR operator, so I will have to check for the next problem also, that if it is true or false. So what is written here? R less than Q. So value of R is, you can see, let me erase this down. The value of R is 6. Okay. And value of Q is what? Sorry, this Q value is changed to 13. Okay. In this case. So value of R is 6 and is it less than 13? Yes, 6 is less than 13. So it will return me true. So now you can see the condition arises here is first statement is false and second statement is true. But according to the logical OR, if any one of them are true, then it will eventually return me true. And you can see the second statement is true. So it will return eventually me true. So the whole condition inside the if return me true. And when the condition inside if is returned me true, then I have to execute the instruction written inside the if. So these two instructions are written. So I have to execute these two. Now, so first statement is Q equal to R XOR Q. Now. So R XOR Q, 6 XOR 13. I already have done this. No, 6 XOR 13. And it will return me what? 11. So I don't have to do anything again. This thing, same thing again. So I will simply return the answer as 11. So 11 will be returned and 11 will be stored where? 11 will be stored in the Q. So Q will now become 11. Okay, so new value of Q will become 11. Now again, same instruction. Q equal to P plus Q plus P. So P currently 5, Q is 11 and P is again 5. So 5 plus 11, 16 plus 5 will become 21. So now 21 will be returned and it will be stored again in Q. So no new value of Q is become 21. Now I come out of this if. Now is I have to need to execute this else? No, because I already executed the if condition. So don't need to execute the else again. So I don't have to execute this again. Okay. Now I come to end of the if condition. Now print the value P plus Q plus R. So my P value is 5, Q value is 21 and R is 6. So 5 plus 21 plus 6 will eventually will be equal to 32, which is this option. So first option is the correct option for this case. So I hope you understand the pseudocode problem that I want to tell you, that how actually you able to solve the problem. Okay, so I also told you the some tricks, tips and tricks to solve the pseudocode very fast. Okay, so now this is the pseudocode portion of the video. Now we will be moving to the coding portion, but before moving to the coding portion, I want to inform you about something, that the online study for you has bring you a great package. If you are preparing for Accenture examination and you have been your Accenture examination in some weeks or some months, then you have to look at this Accenture crash course where you will be provided the 10 free mock test series from our side. Okay. And let me show you what are the contents that are going to be available for you, that you can see here. All the topics that are being asked in Accenture is being covered here. You can see reasoning, complete course and previous year questions, pseudo codes that I have explained you here. Here in this course, there are hundreds of pseudo code are been explained to you that are to be asked in your examination previously. Okay. Now cloud and networking videos also will be provided there. Verbal ability video also will be provided here. Coding video will be provided there. And in addition of that, 10 free mock test series will be available to you, from which you can access that, how your preparation is going and in what topic you have to improve more. Because by giving test series, you will be able to access yourself or access your preparation. Okay. So let me show you the content ones also. You can see there are all the video of all the topics being provided here, and we are also adding the recent question that are being asked in recent examination, like that we like the question that I'm explaining you here. More such video will be available in that course to you. Okay. And if I want to show you the reasoning video to you, you can see all the topic has been covered in very much detail. You can see the duration of the video is also very much sufficient for you to clear the concept of that problem. And over that, if you see the price, it is merely a 500 rupees, nearly 500 rupees, and that also available to you in a 50% discount. So I recommend you to check out this course one. Okay. So that you will be able to crack this examination in very easy manner. Okay. So now let's move to the next portion, that is the coding portion of that video. So now you can see the problem. Okay. So here the problem statement is being written string operation. Okay. Now the problem is we have to implement a function named as difficulty function. Okay. Okay. And inside there are two argument is been passed, that are string and the length of the string. Okay. Now the function accept a string str, that is the name of the string, and the length as the length of the string. Okay. Now string contains, you can see, okay, let me zoom it something. The string contains space separated word. Okay. The string will contain different words that are to be separated by spaces. Okay. And a word is hard if at least two of the condition is true. Okay. If any of them, the two condition, that is this two condition is true, then we can say that word inside that string is to be hard. Okay. So now the first condition is there are more uh, constant than vowel. So what is the constant and vowel? It has been written here also, and you know that. And in English alphabet, out of 26, there are 5 vowels, that are A, E, I, O, U, and rest all of them are consonant. So if inside a word there are more than number of consonant than a vowel, then we can say the word as hard. Or if this is not true, then we can check if there are three consecutive constant. What is consecutive? That means they are occurring one after another. Okay. So if there are three consecutive constant in a word, then also we can say it hard. So if at least one of them, so if any one of them are true, then we can simply say that it is a hard word. Okay. And if it is not hard, then what it is? It is a easy word. So if it fails to in both of them, okay, if it fails in both of the conditions, then we can simply say that the word is a easy word. Okay. Now this is the simple thing. Okay. So here again, one more thing is given, that difficulty quotient, and the formula of difficulty quotient is being given as 5 into hard minus 2 into easy, where hard is the count of hard word in the string and easy is the count of easy word in the string. Now, the inside the note, instruction is then given that we have to return 0 if string is null. Okay. If str contains only lowercase, alphabet, and spacing. So str, that is the string, will contain only the lowercase. Lowercase will mean smaller value of AE. Okay, A to Z will only contain. Now outputs lie within integers. Okay. So the whatever the output is coming, it will only lie in the range of integer. Now you can see one example test case is been also provided and the output is being provided. So let's first analyze this string. So you can see in this string, if you see carefully, let me zoom first. Now, so inside this, you can see one space is been there, one space is been there, one space is been there, and one space is been there. So these all are the words, the segregation of the word. We can see inside the string there are four words. First word is this, second word is this, third word is this, fourth word is this, and fifth word is this. So we have to analyze every word inside the string and tell it if it is a hard word or a easy word by using this two conditions. Okay. So let's analyze the first. Okay. So first is what is the first word inside the string, that is the okay. First word is Q. Uh, what is this? It is actually, I think, I. Okay. QIEWLDOAA. Okay. QIEWLDOOA. Now, first analyze this word here. Okay, let me change the color. So, if you can see it carefully, first we have to count the number of consonant. Okay, how many consonant are there? One. This is a consonant. Two consonant. Three consonant. Four consonant. Okay, so four consonant are there. And vowel, how many vowel are there? One, two, three, four, and five. So now the first condition, what is? If our consonant is more than vowel. So now you can see in this word, the consonant is less than vowel. So first condition is not verified for this word. But now we have to check if second condition is also verified or not. So we have to find three consecutive consonant. Okay, let me erase it from here. Okay, okay, yes. I have erased all of them by mistake. Don't worry, I will write it again. So QIEWLDOAA. Now we have to find the three. You can see this WLD. These are the three words that are consonant and they are all together. Okay. So now this condition is verified. Although this is not verified for this case, but the second position is verified. So we can simply say the first word is as hard word. Okay. I hope you understand. So first word is hard. So now you can see, let me raise the count hard here. It will contain the count of hard, and easy will contain the count of easy word. So first word is hard. So I will increment the count of hard by one because the first word that I check, it is a hard word. Now I will go and check for the second word. Second word is actually a life. Now inside the life, I will have to check the count of consonant again. The consonant count is one and two, and the vowel count is again two. Understood this? Now, again, you can see the first condition is not verified because first condition will tell you the count of consonants should more than the count of vowel. But here count of consonant is equal than count of vowel. Now I have to check for the second condition, and you can see second condition is also not verified here because we can't find any three consecutive constant in the word. Okay. So this both of them are not verified. So it is a easy word. So now I got a new easy word, so I will increment the easy count by 1. Let me raise it again. Now again this word is also checked. Now this will become get me easy. Now I have to check for the next word. The next word is ACE. Okay. So what ACE will get you? So ACE, you can see count of consonant is what? Counts of consonant is 1 and count of vowel is 2. So again, you can see first statement is not verified. Now I have to check for the second statement, and it is also not verified because I can't find three consecutive consonant in that word. So it is again a easy word. Okay. So let me write it easy. So increment the count of easy again by 1. So it will now become 2. Now it is again an easy word. Now I will have to check for the next word, that is by. Now count of consonant in the by is 2 and count of vowel is 0. And you can see the first statement is verified here. So now we can easily say that it is a hard word. Okay. So it is a hard. So let me increment the count of hard by 1. Now I will have to check for the last word, that is fantasy. So inside the fantasy, the count of consonant is 1, 2, 3, 4, and 5. And count of vowel is 2. So you can see the first statement is verified here. So it is also a hard word. So increment the count of hard by 1. Now hard will become 3 and easy will become 2. So it is a hard again. Now I will have no other this word to be checked in the string. So I will stop my checking here. Now what I will do, I will have to use this formula to get my answer. And the formula will say me 5 into hard minus 2 into 3. Okay. So 5 into hard will be equal to 5 into hard minus 2 into easy. So hard is actually 3. So 5 into 3 minus 2 into 2 because easy is 2. So it will equal to 15 minus 4 will eventually get me 11 as my answer. So my answer is 11. You can see 11 is being returned here. So I hope you understand that how actually this code is working. What actually I have to do. Now let's see how I will do it in my code. Okay, I know approach. I know how actually the question is being implementing or how answer is coming. Now I have to write it in my coding language. So what first I have to do? I first have to iterate over the string and uh, check for every word that if that word is uh, what you can say hard word or not. And how you understand that you check for a word, there is a notation that behind every two words there is a space separated. Okay, so whenever we encounter space in our string, then we know that okay, let's understand, try to understand it, okay, in detail, then we will go move forward. Let's say uh, let me on the front. Okay, now let's assume if I is pointing to this now. So I will iterating over this string. So I will be pointing to this. Now I will check if this is a consonant or not. So I will check if it is a consonant or not. Okay. So it is a consonant. So I will increment it. Okay. Again, I will go and check if it is a consonant and vowel. I will increment my consonant and vowel according to that. Okay. Okay. Let me write it this. Let's make it Q I E W LDOAA life, and the next word is by fantasy. So this is actually the string that I am implementing. So now let's see carefully, very carefully. Okay. So what actually I have to check the two conditions. One condition is count of consonant. Let's see will be consonant count will be greater than vowel. So it is first statement and three consecutive consonant. Understood? If any of them are true, then we simply say that string is hard. If none of them are true, then we can say the word is easy. Now we have to check for every word, and the every word is separated by what? Separated by a space. You can see every word is separated by a space here. Understood them. So now we are, let's say this string is str. Okay. So what we are doing? First, we have to initialize the count of consonant as 0. Okay. Let me consonant as 0 and vowel as 0. Because initially when we are starting, there is no consonant and no vowel. And this is for checking the first condition. But for checking second condition, what we have to do? We have to keep our three consecutive consonant count also, that if anywhere I found the three consecutive consonant to be occurred, then I simply say that I found the second condition and the word that I am checking into is a hard word. So for that, what I will do, I will create a Boolean type of variable, and let's say name it as 3 uh, constant, or you can see consonant. Okay, 3 consonant. Let name it as anything you can name it as. Let's say name it as temp, and initialize it as false. That means that I initially, when we are starting to check any word, I do not find the 3 consecutive consonant, and also I have to track the count of the consonant that are occurring consecutively that I stored in, let's say, A. You can name it as anything. Let's say it will be also initialized to 0. So this will be for checking the second condition, and this will be checking for the first condition. Now what I will do, I will have to do, I will go to this, I will move to this. Now I will check if it is a vowel or consonant. So simply check that if it is a consonant, okay? And how you will check? You will check if it is equal to any vowel. There are 5 vowel. If it is equal to A, if it is equal to E, if it is equal to I, if it is equal to O, or if it is equal to A. If it is equal to any of them, if this character at this place, then you can see. Otherwise, it is a consonant. Okay. So we start checking from this. Okay, let me uh, change my pen. Okay. Just okay now. So first starting from this. Okay, so what is this? It is a consonant, obviously. So let its consonant count will be initially 0. Now it will be 1. Okay, because I found a new consonant. Now check it here. It is a vowel, so vowel count will become 1. Now again this, it is again a vowel, so vowel count again become 1. But what about this? This is for checking for the first condition, but we also have to check for this condition as well. It is the condition for checking 3 consecutive constant or not. So it will be invoked when we found a constant. Okay, so let's say I have to write pseudocode if str of I is equal to vowel. How it is vowel, I will tell you in the coding part, don't worry. Okay, if str of I is vowel, then what I will do? Well, I will do one thing. Okay, uh, I will increment the count of vowel by 1, obviously, because I found a new vowel, and I will reinitialize this a equal to 0. Okay, what it means, don't worry here. When I will be explaining you in constant term, then you will explain. Okay, and else, if this is not vowel, then it obviously will be a what? Consonant, because there are only two possibility. If it is a vowel or a consonant for a character inside a word. Okay, now if it is a consonant, then we increment the consonant count by 1 because we found a new consonant. And for checking the second condition, keep tracking for the second condition, we increment the count of A also by 1. What actually A will contains? A will contain the count of continuous consonants. Okay, so you can see, and we check if our A will now become 3, then we get the 3 consecutive consonant, and we simply change our temp to true. Okay, so whenever our A will become 3, then we simply change our temp to true. Okay, now let's try to write on this code. So first, we are starting from here only. So this is a case. Okay, so now Q is starting from here. So it is a consonant. So we'll come here and let's say this is a V count, this is a C count, and this is a A count. Okay. So now V count is become, initially it is 0, it is 0, and it is 0. So I found a first consonant. I will become my first consonant to 1. Understood this? Now, what I will have to do, I will again have to increment my A also to 1. That means that I currently have one consecutive consonant, because you can see till here you have only one consonant, and you increment the count of A also by 1. That count, store the count of consecutive consonant. Now, when we come here, that is I. So it is a vowel. So this condition will be invoked. So now V plus plus will happen. So V now will become 1. And now A will again become 0. That means I found a new vowel. So now the consecutiveness of constant will be ended, because consecutiveness will, let's say this is a constant, let's say C is a constant, D is a constant. And when E is occurs, and again, let's say F is occurred. So we can say these two are consecutive. But when this will occurs, a new vowel will occur whenever, then now again the new consecutiveness or constant will again restart from here. Okay, let's say if you don't understand that C D E F G. Now you can say what are the length of consecutive constant, or what are the consecutive constant. You can see these are the consecutive constant and these are the consecutive constant. Why? Because this E occurs between them. If E is not there, if only C, D, F, G is there, then we can say all of them are consecutive consonant. So whenever a vowel are occurred, then we simply have break our consecutiveness of the constant. So we reinitialize our consecutiveness to 0. That is the case. Now, again, when we move to E, again, E will increment our vowel because E is a vowel. So our vowel will become 2 and A will be 0. It is already a 0. Now, when we come to W, then W is a consonant. So we increment our count of consonant by 1 and we again increment our A by 1. And again, check if A equal to 3. No, A is currently not equal to 3. So don't do have to anything. Now, when we come to L, so L is a consonant. So again, our consonant count will be incremented by 1. Okay, it is 2. So consonant will be 3. Okay, and again, A count will again incremented to 1. It will be 2. That means that I found here you can see A equal to 2 means I am currently at L and you can see there are two consecutive constant till there, and that will be stored in A. Now I have to check if our A is equal to 3. No, that means that we don't have to do anything. Go to the next. When we come to D, now D is again a consonant. So I have to increment my count of consonant by 1. It will become 4. So now what I have to do, I will simply go and increment my A to 1 also. That is 3. Now you can see my A equal to 3. It is true. So I have to change my temp to true. So now my temp is become true. That means I found a 3 consecutive consonants. That is this. Okay, sorry. So these are the 3 consecutive consonants and that I found. Okay. Now, so temp is now will become my now true. Now I come to this O. O is a vowel. So I have to increment my vowel count to 1 also. So it will be 3. And now again, my A is in a slice to 0 because now my streak of the consecutive consonant have been ended. Now again, I move to this A. Again, it is a vowel. So it will be increment my vowel count. Again, I go to A. It will again a vowel. So it will again increment my vowel count. I hope you understand. Now, after doing, now when I again move, listen carefully, what I encounter? I encounter a space. And what actually space means? That till here to here, whatever the data I have, it is a data of one word. Okay? So it is a data of one word. So whenever inside a function, if my string of I is equal to this, that means that space, then that means that I have ended searching one word and the data will be stored in V, C, A and temp will be stored in there and temp is true. Okay. For this word. Now what I have to check? I have ended searching one word. I have gathered all the data from that word. Now I have to check if that word is hard or not. And let's say if I have hard and you can say easy and hard in a slice to 0, easy in a slice to 0, then if str, I have to check what. Now I have to check what is the condition for word to be hard. If it has to verify any of these two condition, okay, and my two condition, first condition will be stored in this two variable and second condition will be stored in temp. So I have to check if my temp is true, then that means that I found a 3 consecutive constant. Then I simply say it is a hard word. Or if my count of consonant is greater than count of vowel, then also I can say, okay, let me this. Then also I can say that this word is hard. And if both of them are false, then I can say the word is easy. So I have to check that if my temp is equal to true. If this is a true, or count of consonant is greater than vowel, then I can say hard plus plus. That means this is a word is hard. So I have to increment my count of hard word. Understood? Else, what I will do, I will increment easy word, because if not this condition will not true, then it is a easy word, obviously. Okay. So now you can see temp equal to true. Yes, temp is true. Even though our count of consonant, that is currently 4, is not greater than 5, but we found 3 consecutive consonant. That means this is a hard word. So I increment my hard word count by 1. Now, what I have to do, I will again, from the next iteration, I will have to check for the new word, that is this word. Okay. The word life. So for that, I have to reset all the variable, that is V, C, A and temp to its original position, because now I have to remove all the data for that word and check. So before moving further, what I have to do, I will have to change C equal to 0, V equal, that means resetting V equal to 0, and then A equal to 0, and again temp is equal to false. It will do actually reset for the next word. Okay. So now after that, I will again do the same operation for this word. Check L, check I, check F, check E, and do according to that condition. If it is vowel, do that. If it is consonant, do that. And after doing this, I will got again a certain data of V, C, A, and temp. Now, when I again encounter a space, then I again go and check that if it is true or it is true. And accordingly, I increment the count of hard or easy of that word. And again, I will reset that value and check for the next word. Again, for the next word, I got some certain data. And again, when I encounter a space, again, I will go there and do the same thing. If it is easy, increment the count of easy. If it is hard, increment the count of hard. Again, reset all the values and do the same for this by also. Again, when I encounter a space, now again do the same operation, that if it is a easy, increment the easy. If it is hard, increment the hard, and reset all the values. Okay. And now again do the same for this. Again, some data is being stored, but try to think, when we I is here, I will perform all the operation. But when I move I further, then there are no spaces. I simply come out of the string, come out of the string. That means I have to do this checking once more outside of the if loop, because for the last word that is to be checked inside the string, there is no spaces at the last. So I have to check this condition even if I come out of the for loop condition. That is, when I am iterating over the string, when I come out of the string, again, I have to check this thing, that if it is a hard word or not for the last word, because for the last word, this condition is not occurs anytime, because there is no last space in the after the last word. Okay. So this is the simple logic for that problem. I know it is a slightly tricky problem that is being asked by Accenture, but I am trying my best to explain all the logic of that problem to you. Okay. Now, I know the video is very lengthy, but let's directly jump to the C++ code that I have already written, because I don't want to make that video even lengthy. And then I will be showing you the Java code as well. Okay. So let's see the C++ code first. So this is the C++ code first. You can see here I am getting the string. Okay. Here I am inputting the string, taking the length of the string. Easy and hard will be initialized. That will actually keep store the count of easy word and hard word. Now int C will actually store the count of consonant for each word. Int V will store the count of vowel for each word. Now, what is the Boolean of 3 con? It is actually mean 3 consecutive, okay? Or 3 consonant, you can say. And initially it is assigned false. I know what I have already explained why I am using all this. And int consecutive C will actually count the consecutive consonant. Okay. Now, what I will doing here, I will iterating over the string from I to I equal to 0 to till the last character of the string. And I am writing first that if that character where I am actually at in the string, if it is a space, that means I have uh, um, done checking one word previously and I have got already stored the data of consonant vowel inside the word. Okay. Or if there is a three consecutive consonant in the word or not by using these two conditions. Okay. So if this is the same condition that I have explained you, that why I'm writing, if any of them are true, if the three constant are consonant are true, or if the count of consonant is greater than vowel, if any of them are true, then I increment my count of hard. That word is a hard word. And if it is not, then I will increment the count of easy. That word is a easy word. And again, resetting will be done here. Okay. So this is simply a reset. That again check for the next case. And if it is not the uh, end of any word, that means that if that is not the, what you can say, the space, if it is either a character, so I have to check if that character is a consonant or vowel. So how I will check? I will write the case for that vowel, that if that is A or E or I or O or U, if the character is any one of all them, then we can say that it is a vowel. Okay. So I will increment my vowel count by 1. Okay. And I will reassign the consecutiveness constant count to 0. I have already explained you why I'm using this. And if it is not the case, okay, if it is not the case, then what I am doing here, you can see that means that that character is the constant. Sorry, consonant. I'm just misspelling it every time. It is a consonant. So I will simply incrementing my consonant count by 1. Okay. And this is consecutiveness count by 1 also. And whenever my consecutiveness count will equal to 3, then I simply mark the 3 consecutiveness variable to true. That means I got 3 consecutive consonant. Okay. That is the sign of that. Okay. Now, what is this? This is the case, what I have told you that here, that I have to check once also after coming out of this, because there is no space for the last word. Okay. So whenever I come out of the iteration of the string, then I have to check once more this, that if the last word is hard word or easy word according to the formula. And then I got the count of hard word. I got the count of easy word, total number of easy word and hard word inside the string. So I simply have to write this formula. It's 5 into hard minus 2 into easy. And whatever the answer I got, I stored it in the answer variable and I simply return it from here. Okay. So this is the simple code. I have already explained you the whole flow through or the logic of that code. So let me run this code for you once. Then you can see that if it is this code is running fine or not. So you can see, okay, something is been, just wait once. Okay, so there are some mistakes. Okay, now let me again run this. So you can see now my code is running fine. You can see for this, that same example I have used, and output you can see is coming same as 11. So this is the correct code that I have written. Now let me show the Java code of the same for you as well. Okay. Okay, just once. Okay, now you can see the Java code for the same. It is the same code. Okay, there is nothing much difference. Now let me run this code for you once. Okay. So you can see the same output is coming as 11. So this is, I thought the video is already very lengthy. So I stop here. I hope you understand the video. If you like that video, then please like this video, subscribe this channel if you haven't subscribed it yet, and comment down if you want me to make more such video, or in this topic you want me to make more videos. Okay, thank you.